All right. All right. So what we got here? Questions and homework?
Yeah, 83.
83.
Yeah.
Where at?
5.
5-1?
Yes.
I guess it's the only thing we've done so far. I guess. Let's see.
This is what
Oh.
we did last time.
All right. 83 and 5-1. It says if P dollars are deposited in an account that pays 5% interest per year, then the amount of money after 3 years is this expression. They give you the formula. You don't have to come up with it yourself. But you can see that there's the 5%. So I don't know if you guys know this. If I want to increase something by 5%, I multiply it by 1.05.
1.
So that's where that comes from. Do you have to know that actually right now? No. They give you the formula. And then they say, okay, so that's the amount of money that will be in the account after 3 years. So then they say, what if you put $1,000 in?
Yeah, P equals $1,000.
You just plug 1,000 plug in your calculator.
So we put the P before we did this one, or
What's always true.
the parentheses. Yeah, parentheses.
And then
put
excuse, yeah, and then my multiplication. Good. Please excuse my dumbass son. Or Deron Sal, whichever one you like. I have something over here.
30.
All right, I'll do that one, and then I'll do that one at the same time. 30. All right, so here's the problem. This here, right?
Yes.
All right, cool. Now, recall. Help me out. What would c to the 7th times c to the 5th? What's that?
C 2 12.
12. You've got to remind yourself. You've got to stop your brain. Your mind has to go brain stop trying to multiply. I don't have a. Let me see if you guys are with me on this. Or you're gonna think I need to take my meds. There is no 7 up there. There's no 7 up here. There's no 7, and there is no 5. There isn't. There are 7 C's, and then 5 more C's multiplying. So how many total C's are there multiplying? 12. So when you say I'm going to multiply the 7 and the 5, I say to you, there is no 7 and 5 up there, right? There is no 7. There is no marker. Is that cool? All right, so how does that apply to what we're doing right now? Well, what can I put together? I have how many A's over here?
2.
And how many A's are there?
1.
So how many A's altogether?
-8.
Yeah, so there's a negative. A to the 3rd. And then how many total B's are there?
5.
5. I like it. And what am I doing? What am I really, really doing? If I said multiply 2 times 11 times 5, I'm going to multiply 2 and 5 first and get 10, because then 10 times anything is easy. Just put a 0 in there. Do you guys understand why was I able to do that? Because when I multiply, I can multiply whatever order I want to. Order operations can't say shit to me because I'm all on the same level. So I can do it whatever order I want to. I'm like, good there. You guys with me there? So what I'm really doing is, please don't do this. You shouldn't have to do this. But I'm going to put the negative a squared and a together. B cubed and b squared together. That's nice. It's going on still.
I don't know what's going on. It just started. My phone's going crazy.
It says you need a musical intermission in that. And I normally agree.
It just turned on. It's going crazy.
I love it.
15 minutes.
I love it. Alright. Are you guys see that? Please don't do this. You can if you really, really need to, but this is what I'm doing. I don't have to actually do it. Now I can just, it's all multiplication, so I can do a squared times a is a cubed. In fact, help me out. What would this be? What's this?
subtracting it.
What's that?
10 x2.
So if anybody's concerned about, well, why didn't you multiply that by the b, and why are you allowed to do that out of order? Why did you put 2 times 5? Because what's 2 times x? I don't freaking know. So I multiply the things I can. So that's 10. And what's x times x?
2 x2.
X squared.
X.
So I am multiplying that x by 2 because it's all together. Everything's multiplying each other in that expression. So, right? So please, dear God, don't make more out of this. It's there's still a negative because there's no other negative to kill it. A squared times a is a cubed. B cubed times b squared is b5. Done. Problem done. Next, please. So whenever you're multiplying, you multiply whatever order you want to. So you multiply the stuff you can actually multiply. You commuted it properly. Look at that. It's awesome. It's just like this. It's exactly like this. What's this? Well, how did you jump over that? Because it's all freaking addition. I can add whatever order. So what are you going to add? Like, I'm going to add the stuff I actually can add. So over there, I'm going to multiply the stuff that I can actually multiply.
So it's going to be 9 plus 4y.
Of course, yeah. That's easy shit. But that's exactly the same idea as this. Exactly the same. It's all multiplication. I'm going to multiply whatever order. So how I'm going to do it? I'm probably going to multiply the stuff that I can actually multiply. The like bases. Here in these like terms, here I need like bases.
60.
Oh, okay. So here's the problem. This is the one this is the one property I didn't quite get to. I don't think it sounds familiar. Not recall, but note. So if I had a squared b to the third power. Now I can say recall. Recall, what would x squared to the fourth power be?
8. X.
X to the 8th, right? Because what does this mean? What does this mean? This means 4 groups of 2 x's. So if I have 4 groups of 2 x's, how many x's do I have? 8. That's the definition of multiplication, right? 4 crates, each crate has 2 apples. How many apples you got? All right, going way back in time. So here, what's really nice, what property are powers based on? What operation, sorry, what operation are properties? Multiplication. So when this is multiplying, this can distribute. So what do you do with the powers here?
6.
So the A6,
And B 3.
B cubed. So now up here, what are you going to do?
3y power
3
4,
to the
4
fourth,
and y
y to the fourth,
and 2 4.
2 to the fourth. Yeah, first thing you do is you distribute the powers. It's incredibly enough, we call it power distribution. These are very creative people. Yes.
Is that how it should be answered?
No, I'm not done. That's the next step. Because a good point. Christina's like, come on, dude. 3 to the fourth. We know that what it is. What is 3 to the fourth power?
81.
81. 3 times 3 times 3 times 3. So it's be 81. Y to the fourth over?
Over 16.
16. 2 times 2 times 2 times 2. So, but the first step is key. You got to distribute that power through. Now, I did talk last time about. Yeah, I'm not going to erase that. Can I distribute the power there? Why not? Why can I not distribute the power?
Because
It's addition, yeah. That's based on multiplication. It's not going to play well with this. In fact, some of you guys know that I had to write that twice and do something called FOIL. That's in our future, our very near future. Maybe today, I don't know. I can't remember how far I'm going to get. Stop there for a second. How are we feeling about that right now? Yes. All right with that? All right. Any other specific questions from the homework? Yeah.
87.
Oh, this is an awesome question. Let me do one like it. This is the one that gets people. I'm going to do this, and that should help you answer that question. Are these the same number?
No.
Oh, I have two different camps going on. Yes, sir.
Yes.
Yes, they are after the
Well, let's try it out. What is this? What do I have two of here?
negative.
I have two negative 2's. The way I just said that should tell you something is happening up there different. So I have two negative 2's multiplying, and when they multiply negative times negative, it becomes positive.
Positive.
Up here, what do I have two of?
Only two.
I have two 2's. I have a negative in front of two 2's.
-4.
So what's that? That's
Negative.
that's 4. So that's -4. So what do if I write this out? I have a negative sign, and then I have two 2's multiplying. That's what that says.
Oh.
Why are these different? Because the parentheses group things for me. So powers are strong, but they only work so far. This 2 is only on that 2. It can't also mean that. It can't. The parentheses here help it mean the whole thing. It's the same thing now. Now watch. This is related. So that's -4, and that is 4. That is a classic thing that students. When you plug this in your calculator, if you just put -2 to the second power, you'll come up to me and you'll say, "Look, teach, all this shit you're saying is wrong. I squared it, and it came out negative. You said when you square something, it comes up high." I'm like, "Well, you put it in there, freaking wrong." Right? That you got to tell the calculator
I answered it right.
what you're squaring. All right, maybe. So this is related to this. I get people that tell me this. What did this person do wrong? What is being squared here?
Only X.
X is being squared. You see, that's exactly the same thing there. What's being squared here? The 2. What's being squared here?
X.
The X. So that's just 3x squared. Right? Do you guys see that? Are you guys with me? I don't know. Some of you guys don't know how to react because you're like, "Well, of course not, duh." And the rest of you are like, "What the hell are you talking about?"
So you wouldn't be able to solve for 3x squared then?
Well, I mean, if I said simplify this,
Okay.
which I would because it's a little bit of a trick question, but it's a beautiful question. You're like, "All right, I'm done." Right? You just circle here. There you go, Jeff. Good job, Jeff. Good question. I'm not, but if I did that, I'd be like tricking people because then you're like, "I got to do something." You know, so it'd be a trick. I'd force you to do something wrong. That would be evil question, so I'm not going to ask you that question. But if you see this sitting somewhere, you can't just make it 9x. In fact, if it was this is really getting at the heart of the question. What is this? What am I squaring now?
3 and 6.
3 and x. So what would that become?
9x4.
Yeah. So there's no way in hell to get 9x out of either one of those. So this one, only the x is being squared, so there's nothing to do. This one, they're both being squared, so I can do something.
So, can we do the one that number 87?
No, I did it already. I'm going to let you try to figure out the fact that I did it. If you'll notice, they have basically the exact same problem, just with a 4 instead of a 3. So you should be able to do it now.
If I'm confused on why is it still 9x squared if you already solved the problem?
All right. So I don't know if it's a problem with what the question will look like. So a question could be simplified, and then number 1 would be simplify this, which I would never ask you again. It should be easy, but it might be a trick, right? Simplify this. Okay, I'm done. Just circle it. It's like me saying factor 17. I'm done. Right? You can't factor 17. Well, what is 17? Well, you know. If I said this, simplify this, there is something you can do. Because you can distribute the 2. There's something to do. This one, it's only on the other. There's nothing. What's x squared? I don't know what x squared is. Do you guys see the difference there?
The only thing I'm confused about is, okay, so it's 9x. I get that, but why is it being squared again?
But no. What's 3 squared? Okay, what's x squared?
X to us.
Okay. So I'm not squaring the 9 again. That would look like this. You know, I can't say that's that. Then I'm like, well, when do I stop? Holy shit, that number's going to go to infinity if I keep squaring the damn thing, right? So I square it, and then I stop. I'm done. Why are the parentheses gone? Because they've done their job. Why were they there in the first place? To tell me that both of these were being squared. That's why they were there in the first place. I like it. So don't draw them back in and say, oh, I got more to do. Because then that problem will take you the rest of your life. That'll suck. I'm still working. Okay. Anything else from homework? Yes, sir.
I don't think it's even on our homework technically, but we ran into Y10 plus 1 on number 5.1 on number 26.
Oh, okay. So, all right. So 26 looks like this.
I think you just went over the principle behind it, but I just don't understand.
That's all right. You can ask me anything out of there. Oh. So the overriding thing here is I'm multiplying like bases. What does that mean I can do with the powers? Add them. So then I'm going to get y to the what? What's 7 plus 3 plus 0?
10.
10. Now, you're thinking about, you brought a plus inside when this is all multiplied. There can't be a plus coming out of nowhere. One way you could do this is you could first do, so that's the answer. That's it. 7 plus 3 plus 0 is 10. You add powers when you multiply like bases. That's a fact. But what's y to the 0 supposed to be? It's supposed to equal 1. So I could, very first thing, I could replace y to the 0 with 1.
Yeah, I have Y10 to 1. Plus 1 I mean.
But why is it plus? It's multiplication.
It's
Right, isn't it y7 times y cubed times y to the 0? It's all
the end
multiplication.
result would be Y10 plus 1.
But why is it plus? Are you cool with what I did so far?
Is it times 1?
Well, what's this operation here?
It's times 1.
There you go. Cool. So you can't. The operations can't change.
Yeah.
I like it.
And then number 55. It's x minus y over 3, the third.
I like it. So what is x minus y? If you knew what x and y were, like if x were 7 and y were 5, for example, it would just be a number, right? X minus y represents a number. So what do I want to raise to the third power? I want to
You
raise.
want to raise 1 down to the second and erase the third.
I want to raise 3 to the third power, and I want to raise x minus y to the third power. Yes, sir.
Can we take 1 from the exponent area and move the over 3 by timesing it by one of those 3?
I don't know what you mean.
Never mind.
So if you really want to look at this problem, watch. I want to get us to the point where we don't have to do this, but what does anything to the third power mean? What's 4 cubed? How would you figure out 4 cubed? What would you do?
Times itself.
I like it. So it'd be x minus y over 3 times x minus y over 3 times x minus y over 3. So this is what hopefully you do not have to do, because if that was an 80th power, oh God. But, just to show you once what's really happening, when I cube something, I multiply it by itself 3 times. I like it. And what's x minus y times x minus y times x minus y? It's x minus y to the third power. I like it. So I get there if I put the 3 on this. But if I look at it this way, I get there also. X minus y times x minus y times x minus y is x minus y cubed. Whatever x minus y is, I have 3 of them multiplying. And then 3 times 3 times 3?
27.
27, which is what 3 to the third power is. So you can still just distribute, but that's why distribution works. So it's 3 cubed, which is 27.
So it's x third minus y third?
Nope. And just to show you a concrete example of why that's not true. So we're looking at this here, right? And I'm telling you that definitely this is not the same as this. And you so desperately want it to be, and I totally understand that. But it just ain't. It just isn't. And the reason is, these are based on multiplication, that's subtraction. They can't play well together. That answer is a little bit lacking, I understand, right? But that's the reason why that doesn't work. So how should it work? Can I take this away?
Yes, sir.
Let's investigate this real quick. Give me values for x and y.
5
5 and 2, like I said. Okay, I like it. So 5 minus 2 cubed. What should that be if I do this the correct way?
3,
5 minus 2 is
3,
3. 3
4.
cubed is
27.
27. That's what it should be. So anything that I think I can rewrite this as should also come out to be 27 because that's what this is. If it doesn't, I'm not allowed to do that. Does that make sense? This is one way to kind of explore what you're allowed to do. So if I think I'm allowed to do this, this would become 5 cubed minus 2
Oh,
cubed.
yeah.
5 cubed, what's that? 125, I like it. 5 times 5 times 5, 125. And what's 2 cubed?
8.
8. And 125 minus 8? So I can't do that. I've proven that I can't, because all I need is one time for it not to work, and I can never do this. There. I like it. Are there some numbers that would work for? Sure. But they're only specific numbers. If I want to write this, they have to work for no matter what x and y are. Yes, sir.
Number 12 on 5.3.
Oh, 5-3, we're not quite there yet. We only did 5-1 so far.
Really?
Yep. Oh.
Okay.
All right. Is there anything else? All right, let's get back into it. Let's try out this. Let's see what you guys think about this here. So when you hit something, you know the properties of the stuff in there, but you're not sure how it all goes together. What we'll always save your ass is PEMDAS. It's always true. It's always true, forever. It's not. It doesn't have its own section. It's the whole damn book. So what properties are happening up here? What operations?
Multiplication.
There's multiplication inside, and there's multiplication here, right?
Yes.
What's the other operation?
Parentheses.
No addition up there.
Multi-
Come on, guys. Come on.
Distribution.
Exponents are also up there. I like it because they're the second thing, right? So good old PEMDAS, if you write it correctly. It's going to do inside the parentheses? No. I do exponents. Right? So this is what's going to save you. People try to do x squared times x. No, you can't do that because I don't have 1x squared. I have 3. And I don't have 1x. I have 2. So, I mean, you can't take that and throw it in there. No, you can't do that. You got to first figure out how much of each of these you got, and then you can put them together. So how do I do this first thing?
x2 by 3.
Yes.
x6.
So it'll be x to the 6th,
y12.
y12.
And 2.
We stop there. Everybody with me on that? So the difference is, little side note. When I do x squared times x cubed, that is x to the 5th. I like it. You add powers when you multiply like bases. Because you're making a chain. You got 2 in a row, 3 in a row, so you got 5 total in a row.
I have a question. Maybe it's different because it's a letter. So where you have the x2, y4 to the 3rd power, so if the 3rd power is touching every single one, right? It's touching the x, touching the 2. Why wouldn't it be 3x to the 6?
Oh, no. All right. Real quick, let me finish this point. If it was x squared cubed, like I've got up there, this is x squared, x squared, x squared. 2 plus 2 plus 2 is 6. So that's the definition of multiplication. I got 3 groups of 2 things. So that's x to the 6. That's what we're using here. What's the number in front of here?
1.
1. And what's 1 times 1 times 1? 1. Okay, so that I took care of that. And then how many? And then I don't think you meant this. So I'm not going to say that because I don't want to confuse people. But there's just the 1. If there was a 2 there, then I've got a 4. And I did put the 3 on the 1. It's just why waste time even showing that because it's just going to be 1. I like it. So x squared cubed x6, y4 3 is y12. What are 2 squared?
4
4 x squared is
y4.
x squared. Y squared squared?
4.
Y4. You can't go wrong with square squared. 2 times 2, 2 plus 2, 2 squared, they're all freaking 4. So I don't know if,
I thought the X and Y were like bunched together.
okay.
No. Like, I don't know if I did it wrong or it just looks like that. Because,
So I'm not done with this yet,
okay.
right? Because what can I do now? Let's get to the answer and then we'll see if it's the same and then we'll worry about if you looked at it right. What can I do now?
Open parentheses.
No, we had the exponent.
Yeah, what's the operation between?
Multiplication.
And I can multiply whatever order I want to. So 1 times 4 is 4, right? There's just a 4 there. How many x's do I have total? 8. How many y's do I have total? 16. And everything is still multiplication the way it's supposed to be, right? So did you?
Yeah, I thought the X and Y were like grouped together. You know, like sometimes it's like, yeah.
So all right. This is a very good point. I think you're sort of thinking about. Maybe if I have this, right? When I'm looking at addition, this is a term and this is a term because they're together by multiplication, right?
Yeah.
So this plus is kind of like separating them. There is no positive. There's no addition to separate these. It's one big term that I want to. It's one big term. I just want to simplify that one term.
Okay.
I don't know if that is sort of like what you were thinking about,
Yeah.
or if not, that made sense. Hopefully, right?
Yeah.
I can't quite tell what you're thinking about. Maybe. Okay. All right, let's try another. What about this here?
A plus B. 10. 5. Yeah. A plus B 10.
What do you guys think?
To the power.
Of course, right. I got 2 of these, 8 more of these, so now I got 10 of these. So the thing we got to get over is A plus B looks like 2 separate things, but if I knew A and B, it'd be one number, wouldn't it? So I'm just consolidating how many of that number I've got.
So, okay.
And the main thing there is, how would this be different? I really want to make sure you guys understand why I was allowed to do that first thing. What happens here?
Different. Subtraction and addition.
True, so what can I do?
Leave it like that.
Leave it like that. Kick ass. And again, that would be an evil question to give you because you would feel like you got to do something. I'm not going to give you this question, but I want you to realize, why could I do this? Because the base is the same. So I got 2 of these and 8 of these. Here I got 2 of these and 8 of those. It's just like x squared y to the 8th. It's exactly the same idea. I can't do shit with that. Right? Everything's already together. I can't do anything more with it.
So, for some people, it would be helpful if there was like a letter with an exclamation to always stick a 1 in front of it. It wouldn't do it.
Oh, yeah.
For people that have to do visuals.
Sure. I mean, this is always true. If you see an X sitting there, there's a 1 there, there's a 1 there, there's a 1 there. Any of those you got to put in there at any time to help you out. So normally we do that when I'm doing like 3/4 plus 7. Well, what I do, I would bring that understood 1 in. I would actually show myself that it's there, and then I realize, oh, I see. That kind of thing, you can always bring any of these in whenever you need to. Yes, sir.
So A plus B or A minus B within parentheses would be the bases to those exponents.
Yeah, that's the base and that's the base. Since they're not the same, I can't consolidate. I can't say I have 10 of anything.
Parentheses included?
The parentheses are there just to show me that this is one thing. That's one thing. That's A plus. I got
So
2
it's around
A plus B.
base. It's not including in the base. It's not included in the base. It's just separating the base from the other thing.
Yeah, these are separate. So like A is not a base. A plus B is a base. A minus
The
B is a base.
parentheses themselves are not included in the term base.
Yeah, because exactly. I like it.
Operations.
So yeah, that's cool. Because if I wrote this, what does this mean?
B A plus A.
What do I have 8 of?
B.
I have 8 B's. I love it. So why is this there then? Just to show that I have 8 of that whole thing. That's why the parentheses there. That's the only reason. So you're right, Dave.
Negative b, you don't do negative b times negative b times negative b times negative b. You just put negative in front of the result of b times b to the 8th power. For example, if that was a minus b to the 8th, the negative before the b would just be put in front of the result. It wouldn't be.
No. This is the result. I mean, there's nothing you can do there except like write it 8 times and try to multiply it out. I'm not going to make you do that.
Okay, cool.
I like it. We're getting to the point where it's really important for us to start to, when it's in parentheses, it's trying to say this is one thing. It looks like 2, but we know if I knew what x was, that would be one number. So we need to start looking at that like it's one thing. You'll see when we get to factoring, it'll become more important to realize that. Okay. Let's see, what else did I leave out? For 5.1, I think that was it for 5.1. Yeah, cool, I like it. Yes. Oh, all right, here's the last thing from this section. And we know this. Math doesn't care what's in it. What's the property that I have to use here? Distribution. I like it. And when you distribute, now here's a little hint. Some of you guys don't need to do this, so don't look at me and roll your eyes or anything. Just don't do it. If you need to, if this helps, right? That's this times this minus this times this.